So previously I said that anytime you have electricity flowing, you generate a magnetic field. So in this picture right here, I say a straight piece of wire. That's the black long thing. And then I represents the current flowing, or the electricity flowing through the wire. And that's going to generate this magnetic field, which I did in dashed lines around the wire. Now we can make a stronger magnetic field by coiling the wire. And so here the black is the wire, and then this dashed red over here is the magnetic field, okay? And just like a regular permanent magnet, this magnetic field is going to have a north pole and it's going to have a south pole. Now, if we put in an iron core and then wrap our wire around it, then the magnetic field generated can be hundreds of times larger when using the core. So this on your right its magnetic field can be hundreds of times stronger than just a coiled wire without the core. And again, it has a north and it has a south pole to this, what we've called an electromagnet, okay? And if we had a permanent magnet here, say I've put this as our permanent magnet, and this is a permanent magnet down here, since this north is pointing towards this north, it would repel each other. And down here on the south end of our electromagnet, the south and the north are near each other, so they would attract each other. And so I've drawn the north at the top and the south at the bottom, okay, when the current is entering in this direction. But if we put the current in the other direction, then this would become north and that would become south. So depending on which way the current is flowing inside of our electromagnet, the north and the south will flip, okay? And there are also natural magnets. And the Earth is a natural magnet. It has a north and a south pole. And I say here exactly how it is occurring is still, I'd say, unknown. There's lots of theories on how it works, but maybe no consensus on how it's exactly the Earth is generating its north and south pole. The magnetic field is very important because it deflects solar particle radiation from the sun, and this is part of what's called the magnetosphere. And then there's natural rocks called magnetite, or called lodestone, which are iron oxides that are natural magnets that you could find on the Earth. But back to our electromagnet, we can use that to make a motor, specifically a DC motor. And so we need an electromagnet, which I'm shown here in the center as this coils around a piece of wood in blue. And then we need a permanent magnet, which is this back black one. And then we need a battery for the electromagnet. So what I've drawn here in the center is just basically, say, a wooden stick that we have our electromagnet on. And this can spin around. And it's going to touch the wires coming out of the battery. And like I said, if the current is going this way into the electromagnet, then we have north and south like this. And then when the flips 180 degrees, the current's going to be going in the opposite direction. So the north and south are going to change. And depending on that situation, it's going to be attracted to the permanent magnet that we have here. And so that's how this rotation is happening. Every time it goes 180 degrees, the north and south switch, and so it pushes the electromagnet away, and then it goes 180 degrees and the north and south switch, and then it pushes the electromagnet away, and so it just keeps rotating and rotating. If you don't understand that, and which is perfectly understandable because it's not a very good diagram, this is one that we're going to build when we meet, and then you'll see a much more realistic view of what's going to happen.